Hello guys, welcome back to my channel. So in this video, we'll be discussing about heat, transfer of heat, and about this thermos flask. So what is something special in this thermos flask? So let me tell you. So this thermos flask, if you put any liquid or anything in this, any liquid, fluid in this, any liquid in this container, then the temperature would be maintained. Means if it is hot, then it would it would continue to be hot. And if it's cold, it cooler, it will continue to be cooler for a very long time. Okay, this is what the speciality of this thermal flask of Milton. Any thermos flask we can take. So today we'll be understanding why this happens and also about heat and transfer of heat. Let's start. So to understand heat, let's start with an example. So suppose you have an object, you have one object, and you have another object with contact to it. Okay, both are solids. Okay, there are two solids in front of you, and both are connected. One solid is hot. One solid is hot. Means the temperature of this thing is hot. What do you mean by temperature? What do you mean by hot? Temperature is the degree of hotness or coolness. So this is hot, means the temperature of this is more, and we can know by that by this, because the molecules in this solid are always in a rapid movement. They've got a kinetic energy. Okay, so temperature of this is more. The temperature of this is more, degree of hotness or coolness. The temperature of this is more, and there is kinetic energy in these molecules of this solid. Now, the kinetic energy, this is temperature. Temperature is hotness or coolness. Okay. Now, this temperature, this kinetic energy of this, or this energy, which is that, what is that energy? It is the kinetic energy. That kinetic energy from this molecule will come to this molecule. It will transfer. Temperature is the degree of hotness or coolness. And when there is a transfer of kinetic energy from a hotter object to a cooler object, transfer of kinetic energy, then this is called as heat. So heat is actually a transfer of kinetic energy from a hotter object to a cooler object. And this is for sure that the heat, or the transmission of energy will always go from the hotter object to the cooler object, and will make this object hotter. Okay, and this object cooler. And then eventually, after some time, both of them will have the same temperature. Means both of them will have the same temperature. And so this is the difference between temperature and heat. And this is the answer to your question, that what is heat. Now we will look at now we just saw that heat is a transfer of energy. Now this transfer of energy, which is heat, can transmit in three different ways. It can transfer in three different ways. It will always transfer from a hotter object to a cooler object, that is heat. But this would transfer in three different ways. There are three different ways it can transfer. What all are that? There are three. Okay. So the first one is conduction, second one is convection, and the third one is radiation. Both all three of them are very different from each other, and they are the types how energy will transfer. Kinetic energy will transfer. So let's learn those. So the first transfer of heat is conduction. So examples are always better to understand. So here, if there is an object of heated object, okay, here there is an object of cooler object, okay, the temperature of this is more. These are having molecules, right? Both of these objects are having molecules, and we all know that there is more kinetic energy of these molecules, which are hot. This is a hot object, H. Okay, so these molecules are going to collide with these cooler molecules and then it would continue. So if this part gets cooler, this part gets hotter, this part gets more kinetic energy, then this would go to the next, this would go to the next, this would go to the next one. Also it will get kinetic energy. This would collide with this would collide to get this, and this object would have gained kinetic energy more than this. So the kinetic energy here is transferring, the kinetic energy of the molecules is transferring from the hotter object to the cooler object. This is a example of heat. There is a flow of kinetic energy, and this is how the first one is. This is conduction. The energy flows, kinetic energy flows from because of the collisions of molecules, and this always needs a medium, right? So this conduction always needs a medium. So when the molecules are needed, okay? And so if you notice carefully, the molecules are not moving from one part to the other to transfer the kinetic energy. It is just vibrating in its place, and it's making the kinetic energy flow. The molecules are staying where they are, so they are not moving. And this is conduction. Now let's see convection, which is similar to this but a little different. So let's understand. So now we will understand convection. So convection is a type of type of kinetic energy transfer where type of heat energy, we can tell, heat transfer, where the whole molecules or the whole thing moves from one place to the other, okay, to transfer heat, to transfer kinetic energy, right? So the first one was only the vibrations, only the molecules were staying at the place. But in convection, the whole thing, the whole molecule, every molecule, or the whole matter, the molecules go from one point to the other to transfer that heat energy. So let's give an example to understand convection. Now this is the most familiar example I can give. So if there is a container, it's heated up here, and this is a fluid. So always, or most of the time, or always, convection happens in fluids, which means gases and liquids, not solids, okay? It happens. It is always, okay? Now, because the molecules of this gases and liquids can move easily, and in solids mostly conduction happens, which in the solids it only vibrates in its place. Okay, now what is the convection cycle in this? So here, which is closer to the heat source, this part of the water is more heated, right? Temperature of this is more, the kinetic energy is more, and the density of this is less, okay? The density of this is less, so it goes above the cold water, and the cooler water comes down and it gets heated. So there is a convection cycle. This is known as a convection cycle. And so this is a type of transfer of heat energy by the whole change in position of the molecules. The molecules, the whole matter is shifting. It's going from up, it's going down, it's going up, it's going down, okay? So to heat up, or to cool down, or to heat up, this is not heated up, so it will come down, okay? This is not heated up, it will come down to get heated. So the whole matter gets shifted to get to transfer of energy, okay? And this convection cycle will continue till when both the part liquids, we can divide this liquid into two parts, hotter end and cooler end, both of them will acquire the same temperature. This convection cycle will continue. And this convection cycle, as I told you, happens because of density difference, right? Because this is more denser, this less denser, the hotter liquid is less denser than this. Now we'll look at the last heat energy transfer, which is radiation. So both of these which we saw is convection and conduction. Both of them need molecules to move, to make heat energy or the kinetic energy move. And this radiation is a type of heat energy where it does not need any medium. It does not need anything to transfer, right? So it needs a vacuum, it can move in a vacuum, right? So the best example I can give is the sun. So this is the sun, and this is the hotter object, and our earth is the cooler object. So there will be a flow of heat, and so from the hotter object to the sun, it will travel to the heat. It travel to the earth, to a planet. So there is so as we know, the space is a vacuum. There is nothing in here, so there are no molecules. So this radiation does not need any medium to travel. It needs it can travel through a vacuum. So here it is a process of transfer of heat energy from a hot object to a cooler object without heating the space between them. So there is no there is no heating of the space between them, and most easily we can understand that it just radiates heat. It does not need any molecules. It's just a transfer of energy which travels by the means of electromagnetic waves, and it does not need a medium. It can travel through a vacuum. So the three things are very easy to understand: conduction, convection, radiation, and I hope you understood them all three, because this is how heat transfers, and it's very important to understand, and these are very simple. Now we'll look at our thermos flask. Okay, so we'll look at a thermos flask, and we will know that what is there in this thermos flask that is making zero transfer of heat energy. How it's happening. So let me just first tell you the simple thing. Okay, so here is our thermos. Now what we put, if we put some hot tea in this, then it would continue to be heated. The temperature will not change. What do you mean by that? So as we know, the cooler, so in that thermos the temperature is more, and outside it's more cooler. The temperature here inside this is more, and outside it is cooler. So when there is a difference in temperatures, as I told you, there will be a transfer of kinetic energy by the three ways: convection, conduction, convection, radiation. And we have to stop that. We have to stop the transfer of heat. And that's what thermos does. But how it does, let's understand. Zoom in. So to know that, we have to go dig deeper into a thermos flask. See the interior of the thermos flask, what it's made up of, and why it's happening. So I can't do that. So we will just learn that why it happens. Okay. So the interior is just I will draw it. This is the mouth. 1 minute. This is the mouth. Okay, and this is the thermos. Now if you look inside, there's one more lining. Okay, so this is one more container. There is one more container inside the thermos flask. Now this inside container, that's where we pour our liquid. That's where we pour anything. Okay, that's where we pour our liquid, that tea, for example. Now this container inside that, it is made up of glass. Okay, so this glass is a bad conductor of heat. Means it does not allows any heat to go out, or any heat to go out. It does not let any heat to go out, because it is a bad conductor of heat, and this is how it prevents conduction. Okay, so it prevents conduction. So this is made up of glass, and it prevents conduction. For our next one is convection. So this is the walls of our container, outside container, and this is the walls inside the container. Okay, so the space between the molecule, the space between the walls. Okay, so both the walls of our container is vacuum. It does not have any medium. It is vacuum. I hope you all know the meaning of vacuum. And so this thing, vacuum, prevents the heat outlet. Means it does not let the heat go out of this by the vacuum. And how does it does? Vacuum prevents convection. Okay, so there is no medium in here, so there will be no convection. So this helps to prevent convection. So now the walls of this flask is silvered. Okay, so when the heat tries to radiate from this liquid, the silver lining of the inner chamber is silvered. Okay, and this it reflects all the radiation again, so it does not let the radiation go. It reflects, it is silvered, so it is reflecting all the radiation back into the flask, or back into the liquid that we are having. And so this is how it's preventing all three of them: conduction, convection, and radiation. And so this is how there is no flow of heat from this hot liquid to the outer surface. Okay, and we can also, this thermos flask also work in a cooler object. So if we put a cooler object, if we put cool water into this when it's hot sometimes in summers, then it is going to stay hot, because there will be no zero transmit of heat from outside to the inside. And also also when we put hot liquid, there will be zero transmission of heat from this hot thing to outside. And so there is a zero transmission of heat energy. And so this is how a thermos flask works. The principle of thermos flask works. So we are now done with this video. We have learned today about heat, types of heat transfer, and also how a thermos flask does zero transmission of heat energy, kinetic energy. Okay, so I hope you liked this video. I will bring more informative and amazing and interesting videos for you all. So to watch them all and to continue watching them, please subscribe to my channel and also like and share to this video. We'll meet in the next video. Till then, goodbye.